Hi everyone, this is a tutorial for section 1 of the UMAT, where hopefully I'll give you some tips and tricks to help you improve your performance. So I did the UMAT 3 years ago, and it went pretty well. So since then I've been studying medicine. I also worked for a brief period for a couple of UMAT companies, but now I'm working as a private tutor. So if you have any questions about UMAT or medicine, or if you want to get your hands on some resources, or even talk about the possibility of private tutoring, then just please let me know through the email address at the bottom of the screen. But for now I thought we'd get straight into it, and broadly speaking there are 4 different types of questions you can get in section 1. So the 4 are logical reasoning, problem solving, data-based questions, and numerically based questions. So I thought I'd go through them one by one, and then finish off with some miscellaneous ideas and questions and thoughts. So there we go. Number 1, logical reasoning. So hopefully you can read that question. If not, maybe try full screen mode, or you could, hopefully the question will be written down in the description under the video. So I'll just give you a few seconds now to maybe pause the video and have a read of that to get an idea of what a logical reasoning question looks like. Okay, so before solving this particular question, let's have a look at some general tips for dealing with logical reasoning questions. So the first tip is sort of applicable to the whole paper, and I think it's very important to understand. So you are allowed to write on the booklet in UMAT. So why this is a big point is because in past years, and I think it's still the case, the front of the booklet says you're not allowed to mark the booklet. And really all this means is that you're not allowed to rip it up physically. So you're allowed to underline words, draw arrows, diagrams, whatever you want. So draw all over it if it helps you visualize the question and helps you solve it. So the second point is to read through the question properly. Now a lot of tutors and tutoring companies will say to skim read. And if you are good at skim reading, then please do so, because it's a good advantage to have. But if you're not, then that's fine. I wasn't. And it's still important to read through the question properly, because UMAT questions are written in a way which means that if you miss any particular part of it, even a small part, it can change the nature of the question as a whole. So if you skim read over a small section and don't fully understand it, then you could end up answering a question which is different from the one actually asked, which means you'll probably get it wrong. So take the time to read it properly. And in doing so, work out whether you prefer reading the question through chronologically, so that is from the top straight down, reading the information and then the question, or whether you prefer reading the question stem, which is this bit first, to sort of prime yourself with the key bits of information in the information section. So work out whether you prefer going straight through or beginning here and then going back through. Now, even if you don't know the answer straight away, that's fine. Often you won't. The process of elimination is very important. So if you can't work out what's right straight off the cuff, then try to work out what's wrong, because usually you'll be able to work out at least 2 options which are sort of pretty obviously incorrect. So some multiple choice options are incorrect just because they're wrong and they go against the information given to you. Other ones are incorrect because they're outside the scope of the information given to you. So this means that if the information here, for example, just deals with a certain set of information, then that's all you can really take into the answers. So if the answers deal with information external to the information here, then you can disregard them, because you don't know that for certain. You have to make assumptions for these to be true. That'll become more clear in a minute. So it's this point here, the penultimate point. Don't bring any external knowledge into the reasoning process. Just work off what they've given you in the information. And overall, just scrutinize every option you're given, every multiple choice option, because even small inconsistencies can be enough for an option to be wrong. So you have to get really pretty anal and just sort of look at each one and work out which is sort of the most correct. So back to the question. Option A looks pretty good. You can't see too much wrong with that. But again, you're looking for the most correct one. So it always pays to go through each option. So option B deals with the idea of defense mechanisms for the host insect, which isn't really dealt with in the information. So even though it may be true, and it sounds pretty good, we can say it's incorrect because it's outside the scope of the question, as mentioned before. Because really, this bit here about defenses isn't mentioned at all, or even alluded to. So option C deals with the idea of the wasps learning from experience. And again, it's not really dealt with in the information at all. Nowhere does it say anything about how they learn to do this, or whether it's instinct. So we can again rule it out and say it's incorrect because it's outside the scope of the information given to you. Option D, again, while it mentions death for both too few eggs and too many, it doesn't mention which process occurs faster or if there's any difference. So because there's no mention of the rate more quickly, so the rate of death, we can again say it's outside the scope of the question, and it's incorrect therefore. And finally, option E, it's also outside the scope because nowhere does it mention anything about eyesight or visual clues or anything to do with that. So because all four are sort of outside the scope, we can therefore say option A is correct. Even though this isn't the perfect answer, and even though a few of these sound pretty good, again, it's all about being really careful with the language they use and just scrutinizing it and working out which is the best conclusion given only the information given to you. So let's move on now to the second sort of question, which is problem solving. These ones are often considered the most difficult, and they often deal with the sort of people who are ascribed letters. So, you know, in this case it's A, B, C, D, E, Alan, Bob, Charlie, David. So again, I'll give you a few seconds to maybe pause the video, read the question, maybe solve it. Okay. So again, just a few tips before we begin to solve it. So all the tips given to you on the previous few slides about logical reasoning still apply to problem solving. But in addition to that, problem solving questions are often best dealt with by using a table on the side of the page to condense all the information given to you. So this is where being able to mark the booklet becomes really useful, because if you can draw a quick table on the side which helps you condense all the information into something which is easy to read, then that'll help big time. Other tips are to try and think sort of practically, sort of in real terms as such, because often there'll be a kind of a shortcut which you can only see by thinking quite practically about the problem. It's difficult to do, but have a look for them. See if you can find any shortcuts, because there often is one. And finally, the guess and check method. It's often sort of looked down on a bit, and it does take a while, but there are questions, specific type of questions, which are best dealt with using guess and check. So we'll go through that too. So back to this question. So I've got the 4 conditions here, followed by the question. So what I would do on the day is draw up 3 tables on the side of the page, like so. So one would deal with the 5 men, and the first letter of their names, and then the months where they were married, then the 5 women, and the month when they were married, and then the men and the women paired off. So the first dot point is that Charlie's wedding was in March So we can put in that Charlie was married in March, therefore he wasn't married in any other month, and therefore no other man was married in March. So we can begin with that. Second point, Bob was married in May, not to Jessica. So begin with, again, Bob, married in May, no other month, and no one else could be married in May among the men. We can then work out that Bob was not married to Jessica. So we can put in that box there that they were not married. And from that, we can work out that Jessica was not married in May because Bob was and she wasn't married to Bob. Okay, so on to the third point now. So David married Izzy. So again, we can say that David married Izzy, therefore no one else did. And likewise, no one else did. We can also say that because David married Izzy in the month after Hillary, neither David nor Izzy could be married in January, because it needs to be after Hillary. So we can rule out those two in January with these two. We can also work out that Izzy couldn't have been married in March because David couldn't have been, and they're the ones getting married together. And the same goes for May. So we can put across there too. And finally, we know that Hillary couldn't have been married in the final month because David and Izzy need to get married in the month after her. So here we can rule out Hillary being married in May. So now on to the final point. Fiona was married in January but not to Edward. So the first thing, Fiona was married in January. So we can say Fiona January, therefore none of the rest down here. At this point we can also say that because none of the four women so far were married in May, G, Georgia, must therefore get married in May, so I can put that in. And then continue down from here, because you know that Fiona's the one getting married in January, so 2 more. And finally we know that Fiona was not getting married to Edward, so we can put that there. So that's sort of what we know, and therefore, yep. So this is sort of the sum of what we know, which is good to begin with. Now, because I suspect what most of you are thinking at this point is, well, how do we do this in a minute or two, which is what you're given per question in UMAT. Often with these big questions, you'll be given 3 or 4 questions based off the initial premise. So if we move on, the first question is, which of the following is therefore true? Which month was David wedded in? So if we go back, we can see that David could only be married in February or April. So already you cut out 2 options. And from there, you have to work out that the key is that David married Izzy after the month Hillary was married. So we have to have a situation where Hillary was married in 1 month and then Izzy in the one after. So this can't happen because Hillary can't be married in January. This one can't be because Izzy can't be married in March. This is the only scenario which works, with Hillary being married in March and Izzy in April. So therefore Izzy is married in April to David, therefore David is also married in April. So option C is correct. So at this point you'd probably be given a few more questions based off the question which was given to you initially. So if this is a follow-up question, who is Fiona's husband, you can then sort of use the tables you'd drawn up before to answer that. So who is Fiona's husband? Well, we can see from this table that it's either Alan or Charlie. If we go to the second table, we can see that Fiona was married in January. And so if we go to the men's table, you can see that in January it was either Alan or Edward. But from the third one we know that it could only be Alan or Charlie. So therefore Alan is the only one that satisfies both conditions. Therefore, it's Alan. And finally, who did Georgia marry and when? So you can see here that Georgia married Bob. So it's down to option A or C. And from here we can see that Georgia married in May. So just like that, you can say option C, Bob in May. Which is an example of how quickly you can do questions once you've got the initial working set up. So yeah, it pays to read the question carefully and do all the working very carefully. So this is a different type of problem. This is one where guess and check is quite good. So again, I'll give you a few seconds to read that and maybe try and solve it. Okay, so to guess and check, simply begin with option A and say, okay, let's pretend this is true. Let's see if that can be the case. So option A, it's Adam. So if you ask Adam, are you Ben? He'll reply by saying maybe, which he says the response to everything. And therefore that satisfies the question, because he would say maybe. Therefore it's correct. And it's that simple. More difficult examples would include this sort of thing, where you get sort of an add-on to the initial question. So again, I'll give you a few seconds to pause the video and just read the second half here, which is sort of the add-on to the first half, and maybe try and answer it if you want. Okay, so the idea is that you have to ask a question to Daniel, which will get a response from him, which wouldn't be gotten from any of the others if you ask the same question to them. So you need to find the question out of these lot that will get a different response from Daniel as opposed to the rest. And this is where guess and check is again useful. So if we begin with option A, you're not Chris, is that correct? If you ask that to Daniel, the answer would be yes, but because he lies, he'd say no. So no is the answer for Daniel, and therefore no is the answer we don't want to get from anyone else for that option to be true. So if you put that same question, the question here in option A, to Adam, he would say maybe. If you put it to Ben, he'd say yes. If you put it to Chris, he'd say no. So unfortunately, because Chris and Daniel both say no, it wouldn't help identify Daniel. So option A is incorrect. Option B, are you Ben? Again, if you ask that to Daniel, he would say yes. If you ask that to Adam, he would say maybe. And if you ask that to Ben, he'd say yes. So again, unfortunately, because they both, Ben and Daniel, said yes, you can disregard that. And as for option C, if you ask that question to Daniel, he'd say yes. If you asked it to Adam, he'd say maybe. If you asked it to Ben, he'd say maybe. And if you asked it to Chris, he'd also say maybe. And therefore that's the correct option, because Adam, Ben and Chris would all say maybe, whereas Daniel would say yes. Therefore that would identify him individually, and that's how you'd catch him out. So this is a question where really guess and check is kind of the best method of finding out the answer. Otherwise it'd be very difficult to work out logically from the start point how to get down to this sort of point. Okay. So now we'll move on to database questions. These are the sort of ones where you get a graph or a table full of information. I've gone for quite a simple one here, this question. Again, I'll give you a few seconds to read it. Maybe try and answer it if you can. Okay, now what hasn't shown up here on the slide is that it should say on the vertical axis proportion of diagnoses per 100,000. Okay, so keep that in mind. It's a question about the proportion of a population. So the percentage of that population who have a diagnosis, and just pretend there's some arbitrary numbers there. So which of the following can be concluded? Option A. The number of people diagnosed with bowel cancer over the age of 70 is greater than the number of people diagnosed with bowel cancer between 50 and 69 in 2014 in Australia. So also assume that this is a question which is about Australia 2014. So I should have said that. So now, it looks like quite a good option from the start, in the sense that bowel cancer, represented by red, is indeed higher in 70 plus than in this group. The problem here is that if you remember that the vertical axis, which has disappeared, is meant to say the proportion of the population, then this question deals with the number of people. There is actually a distinction there. Because if this is 70 plus group is much smaller than this group here, then it could be that the number of people, as said here, is far greater in this group than in that group, given this is a proportion, not a raw number. So that's a distinction to be made there. It's a classic trick in database questions, the difference between raw numbers and percentages. So that's why A is incorrect. B, again, the total number of diagnoses of lung cancer was greater than bowel cancer in 2014 Australia. Again, you can't assume this to be true, because even though lung cancer is greater than bowel cancer in 3 groups out of the 4 with respect to bowel, there is one group where that's not the case. And if this group here makes up the majority of the data, which we don't know, it may do, then you can't say this for certain. Because if you imagine this is, the biggest group overwhelmingly, then these have little effect on the data overall. And this increase, or this high level of bowel cancer, could be enough to affect the overall number. So that's incorrect too. Option C, a great proportion of people aged between 30 and 49 were diagnosed with lung cancer than bowel cancer in 2014. Good option, could be correct, but it doesn't say in Australia. This is how how anal it gets, because you really need to scrutinize every little detail. And if you don't have in Australia or in 2014 in the answer, you can't assume it, because it sort of implies that this is in the world this option refers to. So assuming this graph refers to Australia, then that's incorrect. And so finally D, fewer individuals over the age of 70 in Australia were diagnosed with bowel cancer than lung. So even though this deals with individual numbers, so raw numbers, you can conclude that because it's within the same sample size. So D is correct. So that's an example of how you can have 4 options which look pretty good on the surface of it, but through either a small distinction between raw numbers and proportion, or a small difference in the way it's phrased, such as in 2014 in Australia, seemingly pretty good options can be incorrect. So that's sort of how you need to look at database questions with quite a lot of scrutiny. So there are some tips. So it's often to do with the difficulty, and this is based on small little subtleties in the way the data is presented. So it may be a difference in units between different parts of the data, or it may be a distinction between raw numbers and percentages, different sample sizes. You may need to convert between different units, between different parts of the data. Just, very small little tricks which can trip you up pretty easily. And if you're doing a calculation which you think is too hard, given you don't have a calculator with you, then you're probably not meant to do it. And you probably made a mistake in interpreting the question. Because UMAT's not meant to test you as a calculator. It's meant to just be fairly basic arithmetic when you need it. So yeah. And also, you won't always get nice column graphs like before. Often the data will be pretty unusual and interesting in the way it's presented. So just maybe Google different types of medical graphs. You know, sort of, there's a classic one of like the chances of developing cardiac issues based on blood pressure and age and different factors, which is a massive table with different axes. Those are the sort of typical styles for this sort of type of question. So yeah, just Google medical graphs, different types of graphs, go through them, try to interpret them. That might help for the day. Yep, there we go. Option D. So finally, numerically based questions. So this is where the question is all about probability or fractions or just sort of manipulation of numbers. So I'll let you read that question again. Just give you a few seconds to pause the video and read it. Okay, so a few tips on these sort of questions. If you're given a question which deals with fractions, like the one before, where we've got you know, half leaving and twice that many being replenished, then it's easy to apply real numbers to the situation to make it easier. Because if you have, you know, begin with 1 and then go to a half, and then double to 1.5 and half to 0.625 and go 1.25 and go from there, it becomes quite difficult. You begin working with decimals. Whereas if you begin with a bigger real number, like 100, or something which divides quite well, like 24 or 48, then it's much easier to go from there. And again, if you find yourself doing calculations which are too complex, then you've probably done something wrong. Or if it's sort of quite complex because the numbers are sort of too big, then you can often round. So if you were dealing with a number like 100,027, you can obviously drop the 27 off the end. And likewise, if you're doing a fraction and it's 0.488, you could probably round it to 0.5. So it doesn't need to be exact, it's just about rounding and then applying real numbers and going from there. So back to this question. Again, I draw up a table on the side of the page similar to that. Obviously it wouldn't be that fancy and you probably wouldn't write the titles in full on the day, given the time constraints. But the idea here is that it tracks over 4 years the number at the start of the year, those that leave, the number regained or gained, and then the total at the end of the year. So if you begin at 24, half that leave, double that rejoin, you end up with that, which becomes the starting number for the following year. And then you go from there, all the way through. So the question was, if this trend continues, the number of players expected to leave in 2014. So from here we can work out that that is number leaving in 2014, 40.5. So we need to find an option which is relative to 40.5 correct. So 40.5 is less than the number of players in 2011. So it's not, because you can see there's not 40.5, it's below that. No, yep, so option A is incorrect. Option B, less than the total number of players who left the club in 2011 and 13. So that is 12 plus 27, which is 39. So 40.5 is not less than 39, so that's incorrect too. Option C, less than the total number of players who left in 2012 and 13. So that would be 18 plus 27, which is 45, and 40.5 is less than 45. So therefore C is correct. And if you go through D, new players in 2011 and 13. that add up to 78. So again, option C is correct. So now just a few kind of additional points which didn't quite fit into any one section. So if you were given a question dealing with this sort of table, which is what we had in the year we did, or I did UMAT, it's important to make a distinction between the sample size and the results for each sample size. So if you looked at this is one form of treatment, this is another form of treatment, and then there were 2 trials conducted. So in the first trial, treatment 1 is better than treatment 2, 60 to 53%, and these are the raw number of improved cases. And in trial 2, again, treatment 1 was again better than treatment 2 by 13%, and there are the raw numbers. Yet if you add up the columns together, you find that overall the improvement on treatment 2 was better. This is something called Simpson's paradox, which is the basis of a question in our year. And the idea is that the weight of the data sits in this one here and this one here, because this is a sample size of 80 compared to these two which have 20. And you can see that in this trial the overall rate of success was higher, and given this is the weightier portion, this comes out in the results overall. So this is the sort of tricks that can occur within statistics that you need to be aware of. So they could obviously ask you questions with this about what would happen if you applied equal sample size numbers, which is more effective. If they ask which is more effective and you went to the total numbers at the bottom, you'd probably go for treatment 2, even though in reality treatment 1 is better with, equal sample sizes. So just be careful and look at the data, see what the sample sizes are, and make sure you understand the nature of it. I just put it in because it's a very common type of question, always has been. This is when you have, it's sort of best explained by reading the question. It's sort of best dealt with by drawing up what is depicted through words. So if Russells are always boozles, the idea is that you draw a small circle. Hang on. You draw a small circle inside a big circle, and you can say that's the Russell group, that's the boozle group, and you go from there and say, doozles are either boozles or losels. Therefore you have boozles and losels as 2 circles together and doozles in the middle, and you go from there and draw up the picture. And then you'll have a question after that, which will ask you something else like, are all doozles losels? And then you have to go from there. So just understand that you can draw on the side and make a visual diagram to work out the answer to a question like this, because they do come up pretty often. You might also get sort of these coded questions where, if medicine, if medicine is coded as this word and surgery is that word, what is the code for urgent? The idea here is that each letter corresponds to another letter in the code. So it's kind of that straightforward. So if you have U, then you go to U, and then U is coded as W, so therefore the first letter will be a W, as it is. And you just go from there and try and find the letters in the word you're looking for, in the other words and the corresponding letters. Often there'll also be some sort of additional pattern in between these two. So in this case, every letter in medicine sort of is corresponded to the letter which comes 2 letters after it. So M, N, O, E, F, G, D, E, F, I, J, K, so on. So you can sort of do that way too. You can go U, V, W, W, R, S, T, W, T, go from there. So that's how you do the code questions. If you had no idea, you could also use a trick for sort of making intelligent guesses, which is where you look at each letter individually going down. So look at the first letter, it's all W, which doesn't tell you much. Look at the next letter, and it's 3 of them are T's, one of them is Q, so you probably rule out B because of the Q. And then again, all I's, 4th letter, T, and then 4 G's. So you probably go for the majority with the G's. And then P, P, M, P, roll out the M, go with the majority, which is P. You end up with D, which is correct. The idea behind that trick is that the marker obviously has their correct answer, and then they have to make up 3, or not the marker, but the person setting the question obviously has their answer, which is D, and then they have to come up with 3 incorrect options, which are quite similar to the 4th. So they don't want to give, they don't make these sufficiently different to allow you to get this right just by getting one part of the pattern correct. They want to make you get every part of it correct. So therefore, that's why they make it so common throughout. Just why you can rule out, or why you can go for the one which has the most common component each time. Again, another sort of tip for making intelligent guesses. If you've sort of narrowed it down to a few multiple choice options, and you're not too sure, and you really have nothing to go on, go for the more general or inclusive option. So what I mean by this, if you've got the 2 options below, option A is very definite. It's saying this will always be the cause, nothing else will be the cause. It's absolute. Whereas B is more relaxed. It's saying it could be the cause, but it could also be caused by a number of other things. There are many variables, so on. So always go for option B if you're stuck at this point, because it's just more, it's because for option A to be correct, you need, it's just so absolute that if any one thing, you only need one thing to make it incorrect, whereas B is so much more general. So always go for the more general option. And finally, just some medical concepts. So you're not meant to know, well, you're not expected to know any of these concepts in the exam. And if a question is given which deals with one of these or another concept, then they will explain it for you in the exam. But if you happen to know what it is before you come into the exam room, and if you prepare by learning these, then it will save you time in that you won't have to read through the explanation of what it is, because ultimately time is pretty important in UMAT. And so overall, these are sort of the points we've gone through today. So work out how you like to approach the questions. Take time, read them carefully, know exactly what the question is asking before you begin doing any working. And to do that, you can underline the key bits, draw on the side to cause and effect, arrows, abbreviations, tables, whatever you want. And if you can't work it out straight off, the answer, then go through the process of elimination by working out which options are just incorrect because they conflict with the information. Work out which ones are outside the scope. Don't assume anything, and just be really kind of scrupulous with going through the details of each option. Look for any discrepancies with the information and the options given to you. Don't be afraid to use guess and check every now and then when it feels like, or you'll come to learn over time when to use it. And then with data questions, obviously the points specific to that are to do with sample size, units, what's being measured. If calculations are too difficult, then something's probably not correct. And you can always apply real numbers to questions with fractions. And if in doubt, look for answers which are more detailed, so longer, and also more inclusive. So that's about it. And if you have any more questions, or any questions, any queries, if you want resources or notes, then let me know. that address. That's about it.